Hi, so ready to look at section 1.6, the last section in chapter 1, which is discussing the design of experiments. So just a disclaimer, this section is a lot of terms and really reading comprehension. So make sure you're reading over this section, and I'll hit the main highlights and have a few examples here to go over. So in the notes, as I said, it's just a lot of like terms and fill-ins. So this is just something to recall that we've looked at. So in an observational study, if an association exists between an explanatory variable and a response variable, the researcher cannot claim, and that is causality. Right? So instead, the researcher can claim association. Right? So to demonstrate how changes in the explanatory variable cause changes in the response variable, the researcher needs to conduct an experiment. Right? So this is just some review that we looked at. So remember, if you're doing just an observational study, we can't say for sure one thing causes something else to happen, right? Like cause and effect. We can say two things are associated though through that, right? But remember, we don't know for sure if that variable, that explanatory variable, is causing that change in the response variable. So in order to get a cause and effect, to get causality, we need to have a design experiment. Right? Alright, so next we'll view some terms, and if you've taken like intro to psychology, some of these terms might be familiar. So an experiment is a controlled study conducted to determine the effect varying one or more explanatory variables or factors has on a response variable. Any combination of the values of the factor is called a treatment. All right. So then next term. So this is an experimental unit, or the next fill in the blank is if we have a human experimental unit, we tend to call that a subject. So the experimental unit or a subject is a person, object, or some other well-defined item upon which a treatment is applied. Right? So the individuals we're collecting the data on, right? So then the next thing, so a control group serves as a baseline treatment that can be used to compare it to other treatments, right? So when we're doing a study, we want to have a control group oftentimes to see, to have this group to compare the treatment group to, right? So people that are getting the treatment, let's compare how that lines up with people who didn't receive the treatment, right? So an example of a control group is if I wanted to, determine the use of a homework system like my math lab, if it increases students' grades in the class. So maybe if we, before we were doing paper, pencil, like out of the book homework, one group of students I would have, just continue to do the book and homework, book homework, paper, pencil out of the book. That would be my control group, and then my treatment group would be those that are using like my math lab, the homework system. Which was just one quick example that comes to mind. So the next definition here, so a placebo is an innocuous, and if you don't know what that term means, it's not harmful, medication, such as a sugar tablet that looks, tastes, and smells like the experimental medication, a placebo might be a procedure that follows the same steps as the experimental procedure but leaves out key intervention, right? So oftentimes, use a placebo so that way the people in the control group don't know they're in the control group, right? We don't want them to know, so they don't behave in a certain way if they know they're getting treated or not treated. Um, so then something else that we have to keep in mind with using a placebo is what's called a placebo effect. So a placebo effect is a beneficial effect produced by a placebo, drug, or treatment, which cannot be attributed to the properties of the placebo itself, unless there. Let's see, that should be therefore. Therefore, be due to the patient's belief in that treatment. Right. So, in other words, if you're doing some kind of study, let's say, I don't know, you're testing the effect on some drug. Maybe you have a drug that you claim makes you smarter, right? And then you give this other group a placebo drug. If they they might believe they're in the treatment or they're getting the treatment, so suddenly they think that they're getting smarter and they act smarter in things, right? So that's a placebo effect. So in other words, they're having they're having this change to themselves because they think they're receiving the treatment, but really they're not, right? So it's all mental to them, right? Essentially. Right. So the next thing I want to talk about is called blinding. So blinding refers to non-disclosure of the treatment an experimental unit is receiving. There are two types of blinding: single blinding and double blinding. Right. So we want to blind who's receiving the treatment, who's not. Right. So in single blind experiments, the experimental unit or subject does not know which treatment he or she is receiving, right? So then, if you're doing a single blind experiment, you would be using some kind of placebo, right? So they don't know they're getting it, right? And just to be clear, just to point out that placebo doesn't have to be like a sugar tablet. That's a common thing. It could also be that they're still getting some kind of treatment, right? So maybe you're doing the treatment the same, you're keeping one thing different, the key intervention, and you're just not disclosing if that's happening or not, right? So it could be a procedure, it could be like a sugar pill kind of thing. So then the next thing to look at is in double blind. Experiments, neither the experimental unit nor the researcher in contact with the experimental unit knows which treatment the experimental unit is receiving, right? So double blind study is, the best option if you can do that, because the researchers that are interacting with the subjects, they might treat them differently, right? So if they know they're receiving the actual pill versus the sugar pill, they might interact and treat them differently. So we don't want that to happen, right? Best scenario is the person giving the treatment and also the person receiving the treatment don't know what's going on, but obviously someone has to know so they can look at that data, right? So for example, a placebo, if you're using like a sugar pill, medicine's an easy example of this. If you're using a placebo, a sugar pill, you want it to look and taste and smell and be the same size and everything as the actual drug. So then you make that happen, and then maybe you just you know, put names on cups, and someone puts the placebo or the treatment in the cups. Someone that obviously knows if who's receiving the treatment, and then the person administering it, they're not going to know, and then when they receive the cup, they're not going to know if they have the actual treatment or the placebo or not. So that would be a double-blind experiment. So I have here an example. So we have researchers wanted to determine the association between number of times one chews food and food consumption. They identified 45 individuals who were 18 to 45 years of age. First, the researchers determined a baseline for a number of chews before swallowing food. Next, each participant attended 3 sessions to eat pizza for lunch until comfortably full by chewing each portion of food 100%, 150%, and 200% of their baseline numbers of chews before swallowing. Food intake for each of the 3 chewing treatments was then measured. It was found that food consumption was reduced significantly by 9.5% and 14.8% respectively for the 150% and 200% number of chews compared to the baseline. Alright, so we have some questions about this study. The first is, what is the research objective of the study? So that is to determine the association between number of times one chews food and food consumption. Right. Part B says, what is the response variable in the study? Is it quantitative or qualitative? Right? So remember, response variable is the variable that is going to be changing, right? What we're measuring. So that is the food consumption. And then we're asked, is that variable quantitative or qualitative? And food consumption is quantitative. Right? So it's it's a value, maybe measuring grams of food eaten kind of thing, right? So then part C, it says, what is the explanatory variable in the study? Is it quantitative or qualitative? So the explanatory variable is the variable you're using trying to explain the difference in the response variable, right? Explain the what's going on in the response variable. So that is the chew level, right? We had 100%, 150%, and 200%. And if you notice, that puts that into groups, and that's not a measurement, so that's a qualitative variable. Part D, what are the experimental units, right? The experimental units are the 45 individuals aged 18 to 45 who participated in the study, right? So then the next item says, how is control used in the study? So control is used by determining a baseline number of chews. Right? Oops, I forgot. I had some typos here, sorry. The number of chews before swallowing. The same type of food is used in the baseline as in the experiment. And also the same time of day, lunch time, right? So some people probably eat different amounts of food at different times of day, right? And also age, 18 to 45 was controlled. Right. The next thing, so it says each individual chewed 100%, 150%, and 200% of their baseline number of chews before swallowing. This is referred to as a repeated measure study since the same participants were exposed to each treatment. The order in which chewing took place, 100% versus 150% versus 200%, was determined randomly. Explain why this is important, right? So in other words, we didn't have the person chew 100%, 150%, and then 200% for everyone, right? They didn't do 100% of their chews and then 150% of their chews and 200% of their chews, right? And that's important because so we're using randomization. So randomization reduces the effect of the order in which the treatments are administered. For example, perhaps the first time through, the subjects are more diligent about their chewing than the last time through this study, right? So maybe the first time through they're more diligent, right? They're more, I don't know, focused, like excited about doing the study versus the last time, right? So we want to try to reduce that effect that's going to happen on our data. Right? So then objective 2, we want to explain the steps in designing an experiment. Right? So to design an experiment means to describe the overall plan and conducting the experiment. So then I have here, so these are steps in designing an experiment. So step 1, we need to identify the problem to be solved, right? So the statement of the problem should be as explicit as possible and should provide the experimenter with direction. The statement must also identify the response variable and the population to be studied. Often the statement is referred to as the claim, right? So we need to, figure out what we're studying, who we're studying, all of those good things, right? Step 2 is we want to determine the factors that affect the response variable. So the factors are usually identified by an expert in the field of study. In identifying the factors, ask what things affect the value of the response variable. After the factors are identified, determine which factors to fix at some predetermined level, which to manipulate, and which to leave uncontrolled, right? So we need to figure out all of those 3 things and those factors, right? So we're going to talk to a content expert and see what what factors make sense here. And then step 3, we want to determine the number of experimental units. So in general, we want to have as many experimental units as time and money will allow, but we'll look at some techniques in beginning of chapter 9 to determine sample size, right? If we have the necessary information. Step 4 is to determine the level of each factor. So there's 2 ways that we can deal with the factors. We can control or we can randomize, right? So there's 2 ways to control. One is we can set the level of factor at one value throughout the experiment, and that would be if we're not interested in the effect that that's going to have on the response variable, right? The other possibility is you can set the level of a factor at various levels if you're interested in its effect on the response variable. The combinations of the levels of all varied factors constitute the treatments in the experiment, right? So another option is we could randomize. So we could randomly assign the experimental units to treatment groups, and because it's difficult, if not impossible, to identify all factors in an experiment, randomly assigning experimental units to treatment groups mutes the effect of variation attributes to factors explanatory variables not controlled, right? So in general, when you're doing some kind of study, there's a million different variables, at play. We can't account for them all, so the randomness kind of helps control for that. Right? That's what that's trying to say. There might be variables affecting a certain thing that we didn't account for, or maybe in that discipline it's not known that impacts that certain thing, right? So we're always learning and trying to do the best we can, right? Remember, we're detectives when we're statisticians. So then step 5 is to conduct the experiment, right? So we can have replication, which occurs when each treatment is applied to more than one experimental unit. Using more than one experimental unit for each treatment ensures the effect of a treatment is not due to some characteristic of a single experimental unit. So it's a good idea to assign an equal number of experimental units to each treatment, right? So, we want to have, let's say 20 people in each treatment group or whatnot, right? We want to have an equal number. And then, we want to collect and process the data. We're going to measure the value of the response variable for each replication, then organize the results. The idea is that the value of the response variable for each treatment group is the same before the experiment because of randomization. Then any difference in the value of the response variable among the different treatment groups is a result of differences in the level of treatment. Right? So then lastly, step 6, we want to be able to test the claim. So this is what's called inferential statistics, what we'll look at the very end of the course. So inferential statistics is a process in which generalizations about a population are made on the basis of results obtained from a sample, right? So, at the very end of the course, we want to be able to have some statistics and do some techniques to try to figure out what's going on in the population, right? What's going on with the parameter, which is a measurement of the population, right? So we'll look at that towards the end of the course. So then a statement here is that a well-designed studies will account for the potential of confounding, right? So if you don't remember, confounding occurs when the effects of two or more explanatory variables are not separated, right? So if we design a study well, we can take care of that, right? So then objective 3, we want to explain completely randomized design. So a completely randomized design is one in which each experimental unit is randomly assigned to a treatment. Alright, so now we're ready to look at example 2. So we have a pharmaceutical company has developed an experimental drug meant to relieve symptoms associated with the common cold. The company identifies 300 adult males, 25 to 29 years old, who have a common cold and randomly divides them into two groups. Group 1 is given the experimental drug, while Group 2 is given a placebo. After 1 week of treatment, the subjects report whether they still have cold symptoms or not. What is the response variable in this experiment? Part A, right? So the response variable would be the proportion of subjects with a cold. Right? So then next we want to think of some of the factors in the study. How are they controlled? Right? So here are some factors that I thought of. It could be gender, age, geographical location, overall health, and drug intervention. Right? Some fixed factors, could be gender, age, location. Right? These aren't changing factors. And then some factors we might want to set at predetermined levels would be the drug intervention. Right? So the next one says, what are the treatments and how many treatments are there? So reading through that, the treatments are the experimental drug and the placebo. Right? Those are two things going on. So there are two levels of treatment. Part G says, how are the factors that are not controlled dealt with? That is, the factors that are not controlled are dealt with by random assignment into the two groups. The next question says, what type of experimental design is this? Right, so this experimental design would be completely randomized design. Part F, we want to identify the subjects. So the subjects are the 300 adult males aged 25 to 29 who have the common cold. Males. Right. So then next, so if you look in the text, you can see figure 7, 8, or 10 in the text, and we want to draw something similar to that to illustrate the design of the study. And this should be who, right? So, see, I'm going to use, I'll use text boxes to illustrate this. So over here, I'm going to put random assignment of males to treatments. Right, so that's kind of like the first part of this, and then this breaks off into two groups. So I'm just going to use an arrow. Right. So then in here I can say, you know, this is group 1, which is 150 males. And then down here we have group 2, which is also 150 males, right? So we did the random assignment. Now we have these two groups. Right, so then here we're going to have treatment 1, which is the experimental drug. And then group 2, so we'll say treatment 2, had the placebo. And then from there, what we want to do is to compare the proportion of subjects with colds. Right, so we would take that data and compare. From both groups. Right, so there's a diagram that just kind of illustrates what we're doing, right? Taking all of our males, randomly assigning them to two groups, applying treatment 1 and treatment 2, and then taking that information and comparing the proportions of subjects with colds, right? So that's what we're looking for there. So now we're ready to look at objective 4. So objective 4 is to explain the matched pairs design. Right, so I have here the definition for matched pairs design. So a matched pairs design is an experimental design in which the experimental units are paired up. The pairs are selected so that they are related in some way. That is the same person before and after a treatment. So, for example, twins, husband and wife, same geographic location, and so on. So there are only 2 levels of treatment in a matched pairs design. Right. So we're pairing up experimental units, right? So example 3, it says an ad for Crest White Strips Premium claims that the strips will whiten teeth in 7 days and the results will last for 12 months. A researcher who wishes to test this claim studies 20 sets of identical twins. Within each set of twins, one is randomly selected to use Crest White Strips Premium in addition to regular brushing and flossing, while the other just brushes and flosses. Whiteness of teeth is measured at the beginning of the study after 7 days and every month thereafter for 12 months. So then part A says, what type of experimental design is this? Right, so this would be matched pairs, right? We're matching with twins, right? So matched pairs design. What is the response variable in the experiment? So the response variable would be the level of whiteness. Right, that's what we're measuring. So then what are the treatments? So the explanatory variable or factor is the whitening method. The treatments are Crest White Strips Premium in addition to brushing and flossing and just brushing and flossing alone. Right, those are the two treatments. Part D, what are other factors, controlled or uncontrolled, that could affect the response variable? Right, so if you think about, what are some other things that could affect the response variable, which is the level of whiteness. So, one that comes to mind is diet, right? So one other possible factor is diet. Certain foods and tobacco products are more likely to stain teeth. This could impact the level of whiteness. Right, so something else to keep in mind. So what's an advantage of using identical twins in the experiment, right? So one possibility is that using twins helps control for genetic factors such as weak teeth that may affect the results of the study, right? So the idea is if we use twins, they're going to have similar genetic factors that won't impact the study, right? So like if you have weak teeth, that's going to impact how things affect your teeth, right? Right, so the last objective in this section is looking at explaining the randomized block design. So grouping together similar homogeneous, remember homogeneous means they have like similar characteristics. So we're going to group people together that have something in common, and then we're going to randomly assign the experimental units within each group to a treatment, and that's called blocking. So each group of homogeneous individuals is called a block, right? So and this assures that we don't get some people with the same traits, we don't get them all in one experimental group, right? So we want to come up with these blocks. So randomized block design is used when the experimental units are divided into homogeneous groups called blocks. Within each blocks, the experimental units are randomly assigned to treatments. Right? So I'll give you an example of this. Example 4. So a marketing research firm wants to determine the most effective method of advertising, print, radio, or television. They recruit 300 volunteers to participate in the study. The chief researcher believes that the level of education plays a role in the effectiveness of advertising, so she segments the volunteers by level of education. Of the 300 volunteers, 120 have a high school education, 120 have a college diploma, and 60 have advanced degrees, right? So like a master's degree, medical degree, law degree, those kind of things, right? PhD, so something after like a bachelor's, right? So the 120 volunteers with a high school diploma are randomly assigned to either the print advertisement group, the radio group, or the television group. The same procedure is followed for the college graduate and advanced degree volunteers. Each group is exposed to the advertising. After 1 hour, recall exam is given, and the number of correct answers are recorded. Right. So this is a matched pairs design. Whoops, no, sorry, wrong. I'm switching gears here, right? And that was what we just looked at. This is a randomized block design, right? And we can know this because our blocks are the level of education, and then we're randomly assigning people within those blocks, those groups, to a different kind of advertising, right? So what is the response variable in this experiment? So the response that we're measuring, if you read through this, would be the score on the recall exam. Oops, should be 2 L's, right? And then what are the treatments? So the explanatory variable or factor is the type of advertising. The treatments are print, radio, and television. Right. And then part D, what variable serves as the block? That would be level of education. And then next we want to draw a diagram similar to figure 7, 8, or 10 to illustrate the design. So I'm just going to pull up what this looks like and show you. Right, so I have the diagram here showing what this would look like. So here it's just showing we have 300 volunteers, and they make up 120 high school, 120 college, and 60 advanced degrees. And then remember, we're putting them in 3 different blocks, so we're grouping them by education level. And then each education level is going to get split into equal groups depending on if they're receiving print, radio, or television. And then after that, we're going to compare their recall exam scores, right? So this is just a diagram, again, just showing that process that we're doing, right? Just to make it more visual, right? Right. So if you're having problems with this section, you know, like I said, this section really is a lot of just reading comprehension. So you know, go slow, read carefully, and you'll be fine, right? Thanks.